Okay, today we're going to look at resonance. And resonance basically means more Lewis structure stuff. So you want to have your Lewis structure sheet out. You will also, the example sheet out. You'll also want the half sheet out that I gave you in class to kind of fill in along the way. So we're going to look at the two examples for resonance on our sheet, and then we'll practice this more in class tomorrow. So resonance just means I can have more than one valid structure. So it's, I guess, in a case sometimes a little bit like an isomer, but resonance means I'll have the same number of things, and then I'll also have the same properties, whereas in isomers sometimes I can get a different property for various isomers. So this typically occurs in elements with double bonds. So let's take a look at the first example, which is nitrite, NO2 1 minus. So I start this out by drawing the electron dot structure, and then I kind of have to do some stuff after that. But we'll start out the normal process that we've been doing with Lewis structures. So nitrogen will go in the middle. It's least electronegative. And then I'll place kind of my oxygens around the outside of that, kind of on the right and the left. Okay, each nitrogen should get 5 dots, and each of the oxygens get 6. Okay, so basically what I need to do after I draw the dots is I need to calculate the total number of valence electrons, and right now I have 24 dots. Sorry, 14 dots. Wow. Not 14. Wow, 17 dots. All right, it's been a long day. 17 dots. Okay. Now, I need to compensate for this extra charge, and that's a -1 charge, which means I've gained 1 extra electron. So I need to add that in to my total. So altogether, I'm going to deal with 18 dots. Now, that extra dot is nowhere on my picture. So I have to physically add that in. Once you've drawn the electron dot structures out, you need to add the other electron to the most electronegative atom. So I'm going to put that on one of my oxygens. I'll put it on the one on the right. So you're going to draw that in. I'll keep this in purple just so we can kind of differentiate. Okay, then I'm going to start putting in single bonds. I always do that first. So let's connect the nitrogens and the oxygens. And now let's see what's left. Well, this oxygen is content. I have 2, 4, 6, 8 electrons around this guy, so he's good. But I don't have it yet around this oxygen or the nitrogen. And I happen to have an electron here and an electron here that's left. So I can make a double bond between these two. So I'll draw that in. So we'll convert those two lonely electrons to a double bond. And this is essentially my structure. Now, with charges, I have to make sure that I have the right placement of dots and bonds to get the charge. So we calculate what is called a formal charge. The formal charge formula is written on your sheet, your notes sheet. Formal charge is just the valence electrons minus the lone pair electrons. So I'll put LP for that. And then minus the number of bonds. Not the atoms that are within those bonds, just the actual number of lines that you drew. So let's do that for each atom. So I have oxygen. I'll do this one on the right or left first. I had 6 valence electrons to start. I have 4 lonely electrons on this picture for this oxygen. And I have 2 bonds on that as well. So my formal charge here is 0, and that's okay. Sometimes you'll get 0. Let's go ahead and look at nitrogen. Nitrogen starts with 5. In my picture, I have 2 lonely electrons, and then I have 3 bonds. So altogether, again, I have a formal charge of 0, and that's fine. Now let's go ahead and look at this oxygen on the right. So I have an oxygen here, and I have 6 valence electrons that I start with. I have 6 in my picture, 6 dots. And then I have 1 bond. So altogether I have a -1 charge kind of hanging out over here because of that extra electron. So at the very, very end, you want to take all of your formal charges and add them together. And whatever that number is, that should match the charge on your specific compound. So I have a -1 down here, and I should have a -1 charge overall, so I'm good. Now, the resonance structure for this, basically you're going to take the double bond and shift it to the other side. So instead of me putting this electron here, I could have added it to this oxygen. That would not have mattered. So my other possible structure could look like this. Okay, and this is the structure I have. So you can get an average of these two structures basically when you have this compound in the lab, or in nature for certain other things, I suppose. But these will have the same exact properties, it's just the placement of the bond is different. So not like an isomer. Isomers will get different properties. These will not. So let's go ahead and look at the next example. And our next example, I'm going to change from what's in your notes. So I'm going to have SO3 2 minus. Okay. Now this one, let's go ahead and calculate the total. So there's 6 dots, total valence electrons. So 6 dots from the sulfur. And then I have 6 dots on each of these oxygens, and I have 3 of those. So altogether, I have 24 total valence electrons. So let me draw those dots out for each of these. So sulfur, if you've noticed, needs to go in the middle because there's 1 of sulfur, so it kind of makes sense to think about it logically, but sulfur is below oxygen in the periodic table, which according to the electronegativity trend means that's less electronegative, so it has to go in the middle. So let's go ahead and take a glance here. I'm going to put my 2 extra electrons in. So remember, I have to add in this charge. So my total dots at the end of that adding should be 26. And I'm going to put those on each of my oxygens. I'm going to put one here, and I'm going to put one here. Now I'm going to put in some single bonds. So let's go ahead and kind of take a look. So let's make a bond here, and let's make a bond here, because that makes each of these oxygens happy. Now the other 2 things that I can do, this oxygen needs 2 more electrons. And yes, these 2 are paired together on the sulfur, but this oxygen needs those. So I can break that pair up and make a double bond with these 2 lonely ones on the oxygen. Alright, so let's, now that we have our bonds drawn, we have to calculate formal charge. So I'll do the formal charge for each oxygen and then the sulfur. So for this oxygen over here, I have 6 to start electrons, 6 dots, and 1 bond. So that's, -1. Okay, then we'll do it for the other oxygen, this one down here. I'll just kind of work around counterclockwise, I guess. It doesn't really matter what order you do it in. So we'll have 6 minus 6 minus a 1. Okay, 6 to start, 6 dots, 1 bond, -1. Let's do this oxygen over here. So I have 6 to start, 4 dots, minus 2 bonds. That's going to be 0. And let's do the sulfur. So sulfur has 6 to start, 2 dots, and 4 bonds. So that is also 0. Now let's add together all of these charges. I have a -1, a -1, and then plus 0 will give me a -2, which should match my charge up here, and it does. So this is a valid structure. Now, the resonance structures for this, basically it wouldn't matter where I put those 2 electrons, those extra ones. I could have placed them in any one of these oxygens at any time. So basically when you want to draw the resonance structures, take the double bond and place it down here, and then place it over here, and those are your two structures. So for example, I can have the double bond, sorry, on the bottom side if I wanted. Just keep in mind that'll change the number of dots on each of those oxygens, so just make sure you're not violating the octet rule for those. And then I could put the double bond on this side as well. So if sulfur, double bond is over here, draw in your dots. Now, keep in mind, sulfur is one of those exceptions. Sulfur, yes, it has more than 8 electrons around it, but it is an exception to the rule. So I don't have to worry about that being violated. Sulfur has the extra D shell, so it has that extra storage, so we are good to go on this. So tomorrow we're going to do some more practice. We'll look at O3 in class tomorrow. So make sure you have the notes filled out. You're ready for your polyatomic ion quiz, and you're ready for a few questions about this video. So, all right, make sure you have got this down. If you need to watch the video again, that's totally fine. And I will see you in class tomorrow.